So let's talk about myself. My name is David Yitzhak. I'm team leader of Big Data and NoSQL databases. Over 24 years of experience with SQL Server, Oracle Sybase, Postgres, application and infrastructure DBA. Also non-rational NoSQL solution like MongoDB and Redis, Hadoop, Cloudera, and Spark. I was Oracle IOLG North Forum administrator in Israel. I have 3 degrees from Israel Technical Institute, BSc, MBA, ME. I also research associates in one of the big organizations, presented all over the world. I can see the lecture. By the way, we present together in SQL Saturday today at night. So this is my lecture, TSQL Windows Function, SQL Server 19. Other lectures, Query Store for SQL Server 2919, TSQL Windows Function, NoSQL SQL Database for Developer Security Officer, SQL Server 1922 Container on Kubernetes, Self-I, NLP, R, and Python, SQL 19 with Polybase and Power BI Desktop. You can see all the lecture and see because the Corona I have lecture, dozens of lectures over the world. So you can see it here. So this is the latest lectures. So this is a little bit about myself. Yeah. Okay. So we can start, okay. So we can start.
Sure, you can start.
Okay, let's start. So we'll talk about intelligent query processing in SQL Server and the following feature, memory and feedback and batch adaptive join. My name is David Yitzhak, DBA. So I'm not a smart man, but I like the smart people who write all these books. I read these books and use them. Latest books about 22 is Bob Ward, SQL Server 22 Revealed, and SQL Server 22 Query Performance Tuning. This is new books, and this is all the books I use, especially from APRESS. My sample database is Wild World Importer. You can download it here. And Adventure Work, this is a link to London, and then you can restore them to SQL Server on Windows, Linux, containers, and Kubernetes. You should install the latest version of SSMS. If you install SQL Server Management Studio, also Azure Data Studio will be installed. So I use the latest version, which is 1.9 release. So I prefer as a DBA to work with SSMS, but if you're a developer, you can work with Azure Data Studio. By the way, if you want to create your environment with SQL Server 22, in 5 minutes, you can do it with Docker. This is the way you can do it. If you look here, you will see. And this is the magic which you create your environment. I don't run it over now, but afterwards you can copy you will copy the backup to your Docker, change the permission to MS SQL, and connect with SSMS. 5 minutes to create SQL Server 22 database and connect. But what I did, this is my test environment. I use Azure SQL database with 3 accounts, and I get a machine with Windows Server 22 and SQL Server 22 already installed. And here I will run my demo. So you can see it here. This is my virtual machine. So let's talk about memory and feedback, MGF in SQL Server 22. The demo step is memory grant feedback in SQL22 demo.sql. I can supply you with the present, so you can practice yourself. So what is intelligent query processing? IQPU next gen. IQPU from SQL Server 17 up to SQL 22 is a family of features to improve the performance and workload with no apps change, minimum effort. You don't have to change the application. You don't have to use query plan guide. It's simply change the performance. But in SQL Server 22, some of the new features require query store, QS. Why? To persist the information of the queries plan. Each feature can disable in case of performance regression at DB level, but by changing DB compatibility level, or at query level using a hint. So if you go to this link, you can see the minimum compatibility level that require of SQL Server 22 feature. You can see it with diagrams. If you go to this link, addition and support feature of SQL Server 22, you can see that what I will talk, which is batch mode that you join, and batch mode memory retrieve drag are enterprise edition feature. You can see it here. Maybe it can change, but currently it's enterprise edition feature. It's not supported in standard web and express. So let's move fast about the theory from the Microsoft documentation before we start the demo. So memory is required to store the rows to be stored by the sort operator. This is the memory we need. If you have a join, you have two inputs, the build and a probe table, probe input. Usually the build table is a small table which is mapped into memory into hash table. In very rare cases, more memory is required for parallel plan operation with multiple plan range scans. But the challenge is to find the right size for the memory grant that the memory that the query optimizer can estimate. So if there is incorrect estimations, there will be performance problem. Why? Because if there is underestimating, query does not enough memory and it will use the disk space on 10 dB. But this is more slower than a ramp, and you have split to disk. If you have underestimating, then other query will be starving and will wait until the memory is released, especially if you have a lot of queries. The symptom of the wait event is resource semaphore. So memory grant feedback develop how memory was actually used compared with initial memory grant at the start execution. So if the memory is higher than the initial grant, memory grant is increased. If the memory is lower, it will be decreased. So it helps to adjust the memory grant size for both batch and load more store operator, batch and more store operator. On SQL Server 17, it was MGF for batch mode, only on column store in compatibility 11, 140. SQL Server 19, it's also for row store operation, the compatibility 11, 150. But know that batch mode with SQL Server 19 can be used with column store, okay? SQL Server 22, it's adding the persistent and percentile. So if you want to use the MGF enhancement in SQL Server 22, you should use the compatibility 11, 140 or greater. So persistent. The queries are stored in a plain cache, but the plain cache can be evicted. Why? If you restart SQL Server, if there's a failover with availability group, if you are using the option recompile, which recompile each time the query. So you have these peaks, you see. So if the feedback is lost in the previous version of SQL Server, memory grant feedback, MGF, should start again, and thus impacting the performance of the fixed execution. Vulnerability. Okay, this is the vulnerability. If you constantly have to adjust the memory grant for the same query over the time, like this, the peaks like this, you can see it here. Yeah, it usually caused because of parameter sensitive plan PSP. Why? Because, for example, one plan need index seek, another need index scan, but if the plan with index scan was first run, then index scan will be implemented for the plan that was using index seek, for example. So in this case, if there are such a peak, memory grant feedback will be disabled itself. How do you know it? Because the attribute is memory grant feedback adjusted, we'll have the value of feedback disabled. Also, we'll have the memory grant feedback loop disabled, but this condition should be disappear with the persistence in query store and the percentile mode of memory grant feedback introduced in SQL Server 22. So, how does SQL Server 22 improve Angular features? First, it persists in the memory side information we will see it in the demo, along with other code information in the query store. And memory grant adjustments are based on the recent history of the execution. SQL Server check the entire history and will consider the 90 percentile. It means it will 90 percentile is the point at which 10 percentile of given population falls below. But know that memory can also waste memory in case when only a small amount of memory is needed. We'll see it. So in case we use percentile guard, you can see that the slope of memory is like this, is more moderate. So the approach avoiding spills. So if we use the percentile, the is memory grant adjust attribute will have the value of yes percentile adjust in the demo. So this is the default for SQL Server 22 or the compatibility level 140. If you want to disable the percentile, we should use memory grant feedback percentile to off. So let's move in quick about the queries. Query processing feedback feature. So memory grant feedback can be disabled at the statement level. In SQL Server 1.7, it was a little bit confusing, but alter database scope configuration said disable page mode memory grant feedback on. Starting with SQL Server 1.9, it's not confusing because you can write alter database scope configuration set batch mode broad memory grant feedback off. To re-enable batch memory grant feedback, SQL Server 17, alter database code configuration set disable batch mode memory grant feedback off. From SQL Server 1.9 and higher, alter scope configuration, blah, 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 batch mode memory grant feedback on. You can disable batch mode memory grant feedback at a specific query with this hint, disable batch mode memory grant feedback. Use it. So, raw memory grant feedback. So, you should, the minimum compatibility level should be 150. And we will see that we have in XML plan is memory grant feedback adjusted, this attribute, which can have the following values. No first execution mean this is the first running, and memory grant feedback doesn't adjust memory for the first compile. No regular grant. If there is no spill to disk and no segment use at least 50 at the granted memory, the memory grant feedback isn't triggered. No feedback disabled. If memory grant feedback continues this trigger and flows between memory increase and memory decrease, the data solution will disable memory grant. Yes adjusting means memory grant feedback has been applied and may be further adjusted the next execution. Yes stable, memory grant feedback has been applied and memory stable is stable. We will see it in the demo. So how do you disable memory grant feedback? Disable raw mode memory grant feedback without changing the compatibility level. For 510 and higher, alter database scope configuration, set raw mode memory grant feedback off. To re-enable, alter database scope configuration, set raw mode memory grant feedback on. Disable raw mode memory grant feedback as hint. You have this hint, use raw mode memory grant feedback, disable. So persistence and persistence. So introduced in SQL Server 22. So it's available for compatibility level 140, SQL Server 1.7 or higher. So to disable persist, we see it. Alter database scope configuration, set memory grant feedback persistent off. Okay, disable persistent. Alter database scope configuration, set memory grant feedback persistent off. Disabling memory grant feedback persistent will remove existing collected feedback. The default setting for memory grant feedback persistent is on. It means keep memory grant in query store. So let's start the demo. The demo is here, and you can run row by row, but I prefer to first we'll go to World Importer and create a table which is sale order details. This is the table. Because this table is a copy of sale order detail, I will use this CTE to select specific row from sales orders and insert it into DBA sales order details, only 2 rows. So insert into DBO sales order, select top 2 from order where order product is 115. This will insert only 2 rows. Now I want to insert about 1,000 of rows. So insert into DBO sales order, blah, blah, blah. Select star from order where order product is 140, go 20. So if you go here, you can see it here. Execute. First, insert 2 rows. Sorry. 2 rows. And then 1,000 of rows. And now we'll create our store procedure. Okay. This is our store procedure. The store procedure used to get all the details, getting process ID details, and select star from DBO sales order detail, product ID equal product ID, order by order quantity. Okay. And after we do this, we should go and set compatibility level to 22, which is 160. Add the database water import set compatibility level 160. And then clear query store and enable query store for IQP. Why we told you IQP in 22 need query store. So add the database worldwide importer, set query store, operation mode read write, query store, capture all. Add the database worldwide importer, set query store, clear all. And then we will go and enable all SQL Server 17, 19, 122 IQP features. So add the database scope configuration set batch mode adaptive join on. Add the database scope configuration set batch mode memory grant feedback on. Add the database scope configuration bots row mode memory grant feedback on. Add the database scope configuration set mode memory mode grant feedback persistent rate on. Add the database scope configuration set memory grant feedback persistent on, etc., etc. And then we'll do a select from C database scope configuration. If we go here, this is our store procedure. And then we go to worldwide importer. Here, run all this. And then we'll go and clean our buffer cache. You can see it here. dbcf pro cache, db clean buffer. Then we will enable query include actual execution plan. See, and run USB get order details PID 115 execute. So this is the execution plan. Sorry. So if we look at this query, okay, USB get details, it will return only 2 rows. So, but if you go here, you see that memory grant info is memory grant info. If you go hover of the select statement, you see that is memory grant feedback adjusted? No, it's first execution. If you go to XML plan, you will see that there is the attribute requested memory, granted memory. Is memory grant feedback? No, it's first execution. It means memory grant feedback has not been enabled because it's first execution. So if we go to our demo, we go here, properties, you see here, note that the number can change from each demo and demo, but you can see desired memory, granted memory, sorry. So because I ran it again, and no first execution. What I did is clean the buffer and then run this. You can see it. No memory grant, desired memory, granted memory, and no, it's first execution. So if if you go to show execution plan, sorry, you will see that in the attribute. You will see that you have in the attribute. You can see it here. All you can see it here. Is memory granted? No first execution. Of course, you can see it from the execution plan, and you can see the desired memory and the granted memory. You can see it here. Desired memory, required memory, etc., etc. So you can see it here. Now we'll run it the second time. In the second time, we'll get here that if you run it now, the second time, you get it. Is memory grant figure adjusted? No accurate again. It means if there is no spill to disk and the statement use at least 30% of the granted memory, the memory feedback isn't triggered. So if you run it now, go here. You can see it here now. And you go to execution plan, properties. With endpoint, you can see it. No accurate disk. Okay, so it means memory grant feedback was not triggered. Now we run the query which return horizontal front. If you run it, the current memory grant will not enough to run this query, and you will see here the sign here on the sort operator. Why? The operator use 10dB and will have this warning, which means operators use 10dB to split that during execution and split level and one split thread. So it means that the memory was not enough and it was split to 10dB. Okay. If you go here, and now this query, you can see it here, thousands of rows, execute. So you can see the red sign here. You can see it here. You can see the warning here. Just a minute. Here's the warning. Operator used 10dB. Okay, but if I run it again, we will get additional memory. So if you look here, the warning has been disappeared. And if we are going here and push on going to property on the XML plan, you can see, yes, adjusting. Yeah, adjusting. So, so you will get additional memory. The warning of sort operator will disappear. Okay, and you will see that the memory is adjusting. It means that memory grant feedback has been enabled and triggered. You can see the desired memory and the granted memory. Okay. Now let's run again the query returning the 2 rows, which means exec USP get all the deal with PID 115. You can see it here. And now we get another warning. Which warning we get here? Remember, the previous query returned thousands of rows. This returning only 2 rows. So if you go here, if you go here, the query memory detected, go here, properties, you go to the warning, you see it here. The query memory grant detected excessive grant, which means we get too much memory, which may impact the availability. Grants as initialized and finally is used. So if you go here, you can see it here. Memory, yes, is stable, but we get this warning. So this is what happened when we run query with fewer with less demand of memory after running a high demand of memory. So this is what we get here, and excess grant. Now let's start a new demo. In this demo, we'll run dozens of rows. We'll clear the buffer cache, and we'll run 2 times the test procedure, which return two different parameters 2 times. Exactly speaking, or the deal PID 115. Okay. If we run this procedure, we'll get no, it's first execution, mean one for the first time, desired memory. And then we run 3 times the procedure, we return 1,000 of rows, PID 140, go 3, you can see it here. And then we run again the procedure with 115, 2 rows. So we have 8 execution, 2 of the 2 rows, 3 of the 1,000 rows, and again 3 times of the 2 rows. So if first we'll clear the buffer cache, and then run this procedure 2. So the first execution means memory, NGF did not execute the memory. First optimization and execution. The second running mean no equivalent, mean no need to trigger MGF. So let's do it. So we go here, clean our buffer cache, and run it 2 times. So if you go here and go on the execution plan, you see first memory get info, no first execution, and here no accurate again means there was an accurate grant. Now we'll go and run 3 times the procedure which return thousands of rows. So if we go here, execution, go here, you can see. Just a minute. Properties, memory get info, you will see no accurate grant. Yes, adjusting. Yes, stable. So what is the meaning? So with parameter 140 returning word false, first yes adjusting means that MGF has been applied and could be later adjusted. Yes, stable. This is the third options. You see, yes, stable mean that the memory grade level is now stable, but currently you know that percentile has been no operate. We have no accurate yes adjusting, yes, stable. Now we'll go and do multiple execution with with 2 rows. Now we'll get the memory percentile adjusting. Let's see it. So if we go here and run it, the 2 rows, which means return only a few rows, and you do not need a lot of memory grant. So execute. So if you look, if you go here, sorry, execution plan, you see the sign here, properties, memory get info, yes, table. Here the percentile adjusting. Now is going to the memory and know what's the history of the memory, and now decrease the memory. So if here the memory grant was, the granted memory is 5760, now it's 5744. And let's go further. Now it's 5720. You can see, yes, but it is adjusted. So you can see it here. So finding this parameter 155, we can see that memory grant persistent adjusting feature has been triggered. And the process will continue to get and get a stable point. So where it's stored in the query plane. So if you go to Microsoft expression, there is a new DMV, there is a new system view, which is called SQL Store Plan. SQL Store Plan, the feature description support 3 options. 1, C feedback, 2, memory grant feedback, and 3, DOB feedback. So if you run this query, you will get information about the last granted memory. So if you go here, you can see. So if you go here, here's the DMV. Run it. You can see here. You can see the the feedback data. You can see it here. Okay, but you can see which feature was triggered, which is only 3 features. Okay, you can see the last memory query granted in kilobyte, which is 57.0. So the last memory kilobyte will be the last memory grant. MGF is now feedback and persistent query store in SQL Server 22. And of course, we have only 2 features: C feedback, memory grant feedback, and DOB feedback. Now, I want to be more crazy. Why? Why more crazy? I wonder for Microsoft documentation, how they did these graphs. So what I did now is to run once 1,000 row, the procedure with 1,000 rows, 2 rows, 1,000 rows, 2 rows. So this means that we have these peaks of memory demand. And I want that memory persistent take these crazy demands from the history and do a slow, and we can smooth the branch size like this. Okay, so let's get crazy and run this, you see. And now, if you look at the execution plan, sorry, something wrong. And now, if you look at the execution plan, you can see the memory grant info. You can see 5696, 5672, 5648. By the way, 5624, and all the time, yes, but still adjusting. Why? Because we have peaks with memory demands. 1,000 rows, several rows. Let's continue. Memory grant feedback. Yes, but still adjusting like this. So this is the way you can do persistent adjusting, and you see that there is no. You can see that from here, this is the graph we get about the memory demand. When the memory demand is what is at T1 is high, then low, high, low, but the memory demand is like this and persistent adjusting. So this is proof it is working. Yeah. So let's go to adaptive join in SQL Server 22. Quickly about the theory. So first version of IKPU SQL Server 22, it was only for column store indexes with adaptive join. But in SQL Server 1.9, there is no need for column store to use adaptive joins because batch mode is supported on row store. So MGF started with batch mode and it has to include row mode. Adaptive join remain a batch mode only feature. So batch mode adaptive join enable us to defer the choice of physical join. You have as join or nested loops. So like this, nested loop the complexity is O(n) is the multiple of rows in each table. So hadron is for a lot of where we have a lot of rows, is very efficient where we have a lot of rows, a quantity of rows. So hadron or nested loop joins, we can defer it until the execution time when the number of rows needed to be processed is known, after the face has been scanned. So we have adaptive join operator, which defines the threshold that is used to decide if you want to switch to nested loop or hadron. So a query plan can dynamically switch to a better join strategy execution without having to be recompiled again. So in the memory, we have two versions of the query plan. One for the nested loop, which is complexity is the number of rows in the table, one table, multiplied by number of rows in the other table, or hadron, which is good for table with a lot of rows, yeah, and the complexity is n log n. So the workload with frequency selection between small and large join input scan will benefit from the most join-on feature. Note that Microsoft use a lot of as join a lot instead of merge join because hadron is more efficient. Merge join is not considered in the adaptive join. Okay. So adaptive join is reducing the higher memory required. Why? Then index table loop join equivalent plan. So this is important. This is for Microsoft documentation. The additional memory is requested as if nested loop was a hash join. If adaptive join switch to nested loop, operation use the row already read by the hash join build. So operator does not read the outer reference row again. So what query store capture in order to force, know that if we use query store, we can capture and we are able to force batch mode adaptive join plan. Okay. Adaptive join operator has the following plan operator attributes. So this is, you will see it in demo. Adaptive plan threshold rows, which mean show the threshold used to switch from a hash join to a nested loop. Estimate join time, what the join type is likely to be. Actual join time between in the actual plan, show what algorithm was automatically chosen based on the threshold. We see it now. So remarks from Microsoft documentations. Typical level should be 140 or higher. Only select statement is supported, not DLL. Join is ready to be executed both by index nested loop or hash join, not merge join. So hash use batch mode enables through the persistence of column store in the query. Or a column store index table being referenced directly by a join. Also use a batch mode on row store. Remember that in SQL Server 1.9 we don't need column store to use batch mode. Okay. In SQL 17, you need a column store, a dummy column store. So if you go to Yitzhak Ben Gun trick, he can create a fake column store like this. Create non-column store, index batch mode on cell order ID, where cell order ID equal -1 and cell order equal -2. It means there is a column store, but there is no population from the column store. So this is the trick of Yitzhak Ben Gun. To do a batch to cause the optimizer to use batch mode adaptive join in SQL Server 1.7. So how do you complete this threshold? So if you go to this link or to this article from Paul White in SQL Performance, he will show you how you can compute this adaptive join threshold, and this is a formula. How it does, it show you exactly how the optimizer compute this threshold when you switch from nested loop to hash join, and how do you draw this graph. So if you go to these links, let's talk about the command to disable adaptive join in SQL 17, alter database scope configuration, set disable batch mode adaptive join on. In SQL Server 1.9 and higher, alter database scope configuration set batch mode adaptive join off. Okay, to re-enable adaptive join SQL 17, alter database scope configuration set disable batch mode adaptive join off. SQL 17 and higher, alter database scope configuration set batch mode adaptive join on. Adaptive join also can use hint, which is a hint to disable it. disable batch mode adaptive joins. So if you add this query, you write here, disable batch mode adaptive joins. So let's start our demo. First, we create the sales order. First, let's create the table and insert some data. So this is the table, DBO sales order, create table sales order details, and we will insert data from sales order details. So if we go here to our demo, memory feedback. Let's go to our demo. So we go to AdventureWalk 17, compatibility level should be 160. We go, sorry. We go to we go to our importer, and we enable all server, all SQL Server IQP feature, batch mode adaptive join, batch mode memory and feedback, and then we enable query store, query store clear all, and query mode operation read write capture all. So we go, here, execute, and we create our table. This is our table, and we then populate it. You can see it here. Insert into sales order, select start from sales order detail, go 50. And then we can see if we run this query, select current product ID, blah, 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 group of product ID, order by one. Just a minute, let the table to be populated. Now I populate it, and we can see distribution of our data. You can see it here. If you go here, you can see distribution. You can see that we have the product ID and the number of this product ID after we populate the table. Now we go to AdventureWorks. Here, quickly our query plan, enable query plan. Include execution plan, and then run the first query, select start from sales order details, join sales order details, on sales order ID, sales order details. We do it join on this product ID, which return 200 rows. You can see it here. So if we go here and go to execution plan, you can see that I didn't create column star index, but we have here adaptive join operator. You can see it here. So if you go here, you can see, if you go here, you see that is adaptive true. Estimated execution mode is batch. Estimated join time is batch. Actual join time is nested loop. And if you go here and look at the properties, you can see it here. You can see it here. A minute. Properties. You can see that the actual join time is nested loop. Adaptive threshold rows is 5, 6, 7. This is adaptive threshold. Yeah. And you can see the end of data was nested loop. You can see that if it was a hash join, then the hash key build is the smaller table, which is, you can see it here, sales order ID, and the prop table. This is the table which will be loaded into the memory, and the prop table is sales order headers. You can see that from the same query, I think it's the only operator which have 3 input, 1, 2, 3. So let's go to our present. So note that the number can change from each run. So you can see that for 100 rows we have we have the adaptive threshold rows. This is that threshold. Is adaptive, it's true. And the actual join type is nested loop. Why? Because we return only 100 rows, and the threshold is 453. Again, it can change from one to one. One the same with 240 rows. We'll get again adaptive join. You can see that the actual join time is nested loop, and we use here a nested loop because we didn't approach the threshold. Now writing again, which return 300 rows, and again the actual join type is nested loop, and again it's adaptive join. Now we run it 450 rows. You can see that it is adaptive join, and the actual join type is has match. Why? Because the adaptive threshold now it changed. See, it changed. It 158.3. So it will switch to hash join, and the key table which belong to memory and the hash key will be based on this table. It says order ID, and the prop table which will be input to this hash match is cell order ID. So if you go here again, the number can change, but let's go here. Let's see. Sorry. So you can see it here. You can see it here. Actual join type is nested loop. Let's run it with 300 rows. Actual join type is adaptive true, and actual join is here because the adaptive threshold is. You can see that the actual join type is nested loop because the threshold rows is about 430 rows. Now 450 rows. Let's run it. And now it switched to, it's still actual join type, it's changed, it's still nested loop. Let's continue. Let's continue with which return more than 1,000 rows. And now if you go here, and you can see that is adaptive true. And now the actual join type is match join. You can see it here. So if you go here, you can see actual join type is match join. Okay, you can see it here. Minute. You can see it here. Actual join is match join. Okay. You can see the prop table and the key table. You can see it here. So let's continue. Here. Again, adaptive join with match join. Why? Because threshold is about 500 rows and return only 1,000 of rows. Let's run a bigger plan. And you see that now there is no adaptive join. Why? Because there is 1,000 rows. So adaptive join is not considered at all. You can see it here. Only a hash match. Again, remember that hash match is very efficient algorithm when we have thousands of rows. It's more efficient than merge join. SQL Server would prefer to use hash match. You can see it here. So let's run with bigger rows. See about, you can see it here. And again, no adaptive join because 134440 rows. But what happens if we want to return only one rows? Select top one from the same join. You can see it here. And there is no adaptive join, only nested loop. So this is what I show you. How do you find when adaptive join is skipped? You have extended event which is named adaptive join skipped. In this case, SQL Server will not consider adaptive join because we're returning only one rows. So why to use adaptive joins? Also, with this case, we return thousands of rows, so adaptive join would not be considered. So now let's play with query store index. So if we go to our demo here, we create a cluster column index on our table. We clean the buffer. A minute, executing. We clean the buffer pool. And we return about 2050 rows. Execute. So let's look what's happened here. You can see it here. Adaptive join has been triggered. And we have 3 inputs. Let's talk about the input. So adaptive join operator has 3 input. The first top input is the bill input. Is executed as the bill input, assuming that the hash join has been selected. Okay. Second middle input is the input that will be executed if the hash join was finally selected. This. Third or bottom input, this input would be executed if nested loop join was selected. This. So actual join selected was nested loop. Why? Because if you look at the cluster in the scan here, the cluster because if you look at the cluster index, because if you look here, because the cluster index seek operator show that only, you can see it here, 130 of 122 rows have been processed. You can see it here. And if you look at the cluster index scan, you see that 0 of all the rows are processed. So if we look here at our demo, you can see it here. So you can see that 205 of all the cluster index C cluster were processed, and here only 0. So this plan was used. Again, this, I think it's only operator that has 3 input. So this is the this is the hash match, and this is the nested loop. Let's continue. Let's continue with this. So we have adaptive joins, and let's look. Actual join type. Actual join type was nested loop. So it can change. Look that when I write the name of previous, it was has match. In this case, it was nested loop. So let's run this. And look at here. Now it's the actual join type is has match join. So let's go to our present. So if there is has match, again in the previous demo it was has match. Now it's a nested loop, but it's a H match. Now the actual join type was selected. It has match. It means that cluster index scan operator was used. And it and if you look here, you see that 540 of all the records were used. But if you could look at the cluster index seek, you can see that 0 of the records were used. So in my case, if you go to our demo, you can see it here. You can see it here. 1605 of the rows cluster index 6 were used. If you go here, you can see 0 of in cluster index 6, 0 of the rows we used. So you can see that hash match hash join was used. So this is a sign. Okay, so again, we have 3 input. If run win 146 the row also has match is used, and we can see the build table and the prop table. You can see it here. And if we run for the 3, 2, 6, 4, 4, 4 rows, a lot of rows, no adaptive join is used. So go here. If you go here, you can see that adaptive join is used, but if you go here, haven't of rows, go to the execution plan, you can see that only has match was used. And adaptive join is not used. You can see it here. So to summarize, adaptive join is a nice feature. You have to use with cautious, and there is no persistent to column store. I show you no persistent to column store. And but it can operate on column store index and non-column store index for SQL Server 1.9. Okay, so this is there, and this feature can be nice with the memory grant info. So this is the end of the lecture. I hope I'm on time. If you have any questions, I'll be glad. Any questions?
I don't see any questions on the chat at the moment, David. Thank you very much for the presentation. It was a great presentation. It's very interesting how the technology evolved. On the previous presentation, I was talking about Query Store on SQL Server 2016, and you just showed an evolution of that, which arrived on SQL Server 2017.
Yeah, I also show in another present that, for example, the feature of parameter sniffing is not all the time works, and you have to use querying, so you should be careful.
Yeah.
And know that FG joins is not persistent to query store. Only the C feedback, the memory feedback, and I don't remember the set feature. Maybe in the next versions.
Yeah, maybe on the next version. But both features, on the previous presentation, showed that Query Store could show us the queries with problems. But the memory grant feedback and the adaptive join that you illustrated, they can solve the parameter sniffing problems. They can, if not completely solve, they will reduce a lot the parameter sniffing problem, because these are consequences. Bad joins and bad memory grants, they are consequences of the parameter sniffing. And from these features, we were able to solve, to reduce a lot the parameter sniffing, and these only continue evolving and evolving. So thank you very much. It was a very in-depth presentation, great presentation. Thank you very much.